In October 2008, ISRO launched the Chandrayaan-1 mission on board a PSLV rocket. There were two payloads, a lunar orbiter and a lunar impactor. The impactor disturbed the surface at the landing site, and collected samples for analysis. The impactor also enabled India to become the fourth country to put its flag on the Moon, after the US, the former Soviet Union and Japan. The orbiter encountered a series of technical problems, including malfunctions of its star sensors and the thermal shielding. ISRO lost contact to the spacecraft well before the planned mission duration of 2 years. However, the orbiter still managed to fulfill most of the goals of the mission, and even managed to find ice in the North Pole of the Moon. In March 2017, NASA used new and more precise ground-based radar to track down ISRO's Chandrayaan-1 orbiter, still going in circles around the Moon. Madhavan Nair, former chairman of the Indian Space Research Organisation, hailed NASA for finding the lost spacecraft. Even before the launch of the Chandrayaan-1 mission, ISRO was already making plans for the follow-up Chandrayaan-2 mission. In September 2008 itself, the Chandrayaan-2 mission was approved by the government for a cost of 4.25 billion rupees. The budget does not include the cost of the GSLV launch vehicle, or the lander. The mission is an important step in India's plans for planetary exploration, a program known as Planetary Science and Exploration, PlanX. ISRO Chairman Kiran Kumar revealed to reporters the timing of the Chandrayaan-2 mission during an event that announced details of the South Asia satellite. When asked about the Chandrayaan-2 mission, Kumar said, "We are targeting first quarter of 2018 for the launch." India's second mission to the Moon is more advanced than the first. There are 3 components of the mission: an orbiter, a lander and a rover. The rocket ISRO is planning to use for Chandrayaan-2 is a GSLV Mark II, and will take off from the Space Agency's launch facility at the Sriharikota in the first few months of 2018. The orbiter will be deployed at an altitude of 100 kilometers above the surface of the Moon. The lander will then separate from the orbiter, and execute a soft landing on the surface of the Moon, unlike the previous mission which crash-landed near the lunar South Pole. ISRO is in the process of testing the actuators and sensors for the soft landing. A rover will then explore the surface. The lander, rover and orbiter will perform mineralogical and elemental studies of the lunar surface. The Chandrayaan-2 mission is being tested at an ISRO facility in Chitradurga in Karnataka. Artificial craters have been created for the lander sensor's performance test. Drop tests for the lander and mobility tests for the rover are also being conducted at the facility. The 6-wheeled rover is going to be semi-autonomous, and its movements will be partially controlled by ISRO. Stations on Earth. In 2007, ISRO signed an agreement with Russia to get technical support for the Chandrayaan-2 mission. According to the agreement, the Chandrayaan-2 mission was supposed to be a joint project between ISRO and the Russian Space Agency, Roscosmos. As part of the agreement, Russia would provide the lander and rover parts of the mission, while India would be responsible for the orbiter. The mission was originally planned for 2015. In 2011, the Phobos Grunt, a Russian sample return mission to one of the 2 moons of Mars, failed. The Phobos Grunt spacecraft was launched along with the Yinghuo-1, meant to be the first Chinese spacecraft to go to Mars. The mission failed, and the 2 spacecraft ended up in the Pacific Ocean. Russia began a review of the mission, and the future of the Chandrayaan-2 mission depended on that review. Russia pointed out that there was a high risk of failure if the rover went up in 2015, and asked India to supply the rover component. ISRO had already been conducting some preliminary tests for indigenous rovers, and had proven its capabilities with the impactor in the Chandrayaan-1 mission. As a result, ISRO undertook a review of the entire Chandrayaan-2 mission. The integrated review recommended that India could provide both the lander as well as the rover components, given a few years. The orbiter was reconfigured to accommodate the Indian-made lander and rover, and the particular scientific payloads on board were finalized. In August 2013, India decided to go ahead with Chandrayaan-2 without Russian tie-up. Russia is still involved in minor ways with the mission though. A Russian company, Isotope, has provided a CM-244 alpha emitter for one of the scientific instruments on board the Chandrayaan-2 mission. The orbiter and the lander will be stacked together and will be injected into an Earth parking orbit. After going around the Earth several times, the orbiter will be inserted into an extremely elliptical lunar orbit, which will be reduced to 100 kilometers over the surface of the Moon after a number of orbits. The orbiter will carry the lander, with the rover on board, from Earth orbit to Moon orbit. The orbiter will survey the landing site before deploying the lander. The primary structure of the orbiter has been constructed, and has been delivered to the integration team in 2015 itself. The integration teams adds in all the components, scientific payloads and sensors to the orbiter. The actual payloads are an effort that involves many facilities across the nation, and are expected to be integrated in the first quarter of 2017. The interface between the orbiter and the launch vehicle has also been completed. The configuration of the lander for a soft and safe landing has been completed. The payload configuration, lander-orbiter attachment has also been finalized. The lander craft will have a propulsion system on board, which will deboost the spacecraft during landing. The lander also has legs, which will deploy during the landing. The legs have been engineered, and drop tests on a single leg conducted. A facility has been established at the Lunar Test Facility in Chitradurga, just for further drop tests of the lander legs. The lander will have on board a radio altimeter, a pattern detection camera and a laser inertial reference and accelerometer package. These three components have already been tested. A system demonstration module for evaluation the propulsion system on the lander, the lander actuator performance test and the electrical packages for the lander are in the advanced stages of realization. The rover is a six-wheeled vehicle that will have on board software that will allow it to roam the surface of the Moon in a semi-autonomous manner. ISRO will be providing partial command and control instructions from the ground. The rover has on board a navigation camera, an inclinometer, and a dedicated imager for capturing pictures of the lunar surface. The three systems have been tested and integrated. The rover will transmit back data from the lunar surface, but there are no plans to actually collect samples of soil, rock or moon dust. The rover is being tested at a special facility in Bengaluru, where ISRO has created the kind of soft soil with fine particles that is expected to be on the Moon. Tests are underway to evaluate the way in which the wheels of the rover interact with the soil. The bits and pieces that make up the Chandrayaan-2 mission come from various ISRO and government facilities around the country. The Physical Research Laboratory is an autonomous unit under the Department of Space in Ahmedabad. PRL is actively participating in ISRO's Plan-X mission, and is developing several of the scientific payloads to be used in the Chandrayaan-2 mission. One of the two instruments on board the rover to analyze rock and soil samples on the lunar surface is known as the Alpha Particle X-ray Spectrometer, APXS. The PRL is developing and testing the APXS, which uses X-rays to analyze the samples. The Space Astronomy Group, SAG, at ISRO Satellite Center is developing a large area soft X-ray spectrometer for the Chandrayaan-2 mission. The Space Physics Laboratory is developing three payloads for the Chandrayaan-2 mission. These are the Chandra's Atmospheric Composition Explorer 2, Chandra's Surface Thermophysical Experiments, and Radio Anatomy of Moon-Bound Hyperatmosphere and Ionosphere, RAMBA. Partners from the private industry have provided some of the sensors and optics on board the Chandrayaan-2. The mission is entirely indigenous, and is more of a technological mission than a scientific one. The primary goal is to test the soft landing capabilities, as well as the semi-autonomous movement of the rover. The mission has deepened the links between the space agency and the private industry, and has fostered the creation of many new indigenous technologies. The mission will allow ISRO to take its scientific studies of the Moon to the next level. The scientific goals of the mission include analyzing the surface samples, and to learn more about the origin and evolution of the Moon. Before Chandrayaan-2, ISRO has another exciting Indian Moon mission scheduled. At the end of 2017, Team Hakuto from Japan and Team Indus from India will both make an attempt at the Lunar X Prize by landing a rover on the Moon. The two teams will ride share on an ISRO PSLV rocket scheduled for a December 2017 launch. The first private Indian company to reach the Moon is expected to do so just before Republic Day, 2018.